Okay, again, another topic that we're going to have is density. Okay. When we say density, I'm going to teach you the simplest way that you can understand what density is. Okay, let us have this activity. Okay, so if we're going to put a water on a glass, so on our setup, okay, so we're going to put a honey or sugar on the water. So after 10 minutes, it will settle down at the bottom. Next, we're going to put cooking oil. Okay. After 10 minutes, it will settle on top. Now, using different materials on this setup, we have coin, tomato, plastic bottle cup, and sponge. If we're going to put first the coin, followed by our tomato, followed by our cup, and last is the sponge. The setup after 10 minutes will look like this. Okay. So you will notice the coin settle at the bottom. Then tomato settle here in water portion. And cup settle at the cooking oil. Last is the sponge settle at the top of the cooking oil. Now, question. What happened to the water on top of the sugar? What happens to the water on top of the sugar syrup? Does it mix or stay separately? So if we're going to look at this one, the question is, does it mix or stay separately? The answer is, it stays separately. Okay. Next question is, do you see mixing of liquids? So the answer will be none. What happens to the oil? So the oil settle at the top. Okay. Which is denser? Water, cooking oil, or honey? Okay. So let us arrange it in order from less dense to denser. So our less dense, if we're going to compare the three, our less dense liquid is cooking oil, followed by less dense also, which is water. Then the denser is the honey. Now, after putting the different materials, where does each drop solid object settle on each liquid? So these are solid objects that we put inside our setup. Okay, where does they settle? Okay, each material settle at different parts. Okay, the coin settle at the bottom in the honey. Okay, then the tomato settle on water. Then the plastic cup settle at the top of the water in between the oil. Then last is the sponge at the top of the oil. Now, what does this activity tells us? Okay. So this is what you call the densities. Different materials have different densities. Okay. So density is the ratio between mass and volume of an object. So every materials have different density. For example, water has 1.0 grams per milliliter. Honey, 1.4. Motor oil, 0.9. Cooking oil, 0.8. So these are their different densities. Okay, now question. How can you compare the density of solid to liquid? So when we say, when we're going to compare the density of solid to liquid, we can say that solid is denser than liquid. So, sir, how are we going to say that solid is denser than liquid. You look at the data. Okay? Tomato reached 1.01, coin reached 8.9, then plastic cup 0.92. Okay? So you look at this one. They have the greater density compared to liquid. Okay? Cooking oil 0.8, 0.9, 1.4, 1.0. Which solid material will more likely to soak in water? From the four materials that we have on our setup, solid materials that we have on our setup, the one that reaches the bottom is the coin. Sir, why is it that it reaches the bottom? Because coin is among the four objects, the coin has the greater or the greatest density, 8.9. That's why it settled in the bottom. Okay. Now, when can we say that an object will float? Okay, an object will float. Object must be less dense than liquid in order to float. Supposed to be, if you want to know if an object will float or not, if its density is lesser than the density of water. Okay, for example, the density of water is 1 and the density of block of wood is 0.65. Since it has less density, definitely the block of wood will float. Okay? Ice. If we're going to have ice is 0.92, less than 1, which is water, it will float also. Okay, next. Plastic bottle, 0.92, less than 1, it will also float. But tomato, 1.01 greater than our water. Let's go back. This is our water. This is our tomato. So it will not float because tomato has greater density than